All right. So, Ivo, I want to show you a silly experiment. And before we get into it, if you will indulge me for a few minutes,
Of course.
I want to show you something. So, a while back on the YouTube channel, before working even on Skia or WebGPU with Johnny Burger, we were doing these fun TypeScript challenges. So, for instance, we were doing arithmetic operations. We implemented the brainfuck language in
Yeah.
types only. Yeah,
Oh my
and I
God,
mean
that's
now
crazy.
it's a well understood topic. All Turing language are equally powerful, and I mean someone even ran Doom using types only.
Yeah.
So I'm not here to really litigate this topic. That being said, since I have you on the call, I thought, okay, let's do quickly maybe a type-only shader, just as a warm-up.
Okay.
And so it's funny because I was not when I had the idea, I was not in front of the computer, and I was thinking, okay, let's do a simple shader, types only. So let's do a circle. A circle is distance to the radius. Basically,
Yeah. Yeah.
is less than radius. And I was like, but distance, we need the square root. So that's not good. But then, so I was like, okay, we'll see. But then I went in front of the computer. So these are like operations we built with Johnny Burger. So this was like 5-6 years ago. So
Okay.
we have addition, subtraction. So distance, it's a square root, right?
Yes.
But we can square on both sides. So we can check if, so let's write it down maybe. So would be square root of that's exactly. So we can that would be the operation.
Yes.
So here we have addition, subtraction, multiplication. So these are power of 2 we have through multiplication.
Yeah.
And subtraction we have, but here we need the absolute distance because in these operators we don't handle how do you say negative numbers.
Oh yeah. Yeah.
So but here it's okay because we square it, so that's all good. And less than is just simple. It's a simple subtraction, and we return a Boolean operator basically. So I was like, okay, so that's doable. So we have less than, which is a subtraction. You check. So because we don't handle negative numbers, if it's negative or 0, it's going to return 0. So it's true or false.
Okay.
The absolute distance, same story. We check if it's negative or not, and then we inverse the true number.
Ooh, okay.
And that gives us the formula that we just had in the comment. So less than the absolute distance of x cx square by same for y, and is less than square radius. If yes, you return a pixel, you're inside. If not, you're outside. Fair enough, right?
Fair enough. Yeah. I'm almost ready to give up the type GPU name for
Types
this,
only.
for type only. Yeah. Oh my God.
So we return a row, we return a column, and we got our shader. So that's, I mean, maybe I need to be better at ASCII to art, but the math is, and it needs maybe some anti-aliasing also.
Oh yeah. That can be added later.
So maybe in type GPU we can, preview the shader as a type definition.
Maybe. I mean, it's definitely possible. Looking at this. Oh my God.
So why am I showing you this? Because that's not what I wanted to show you this morning. So what happened is that, so this was before working on Skia and WebGPU.
Okay.
And I remember when we were implementing this crazy, brainfuck language and these crazy complex type-only challenges. A very useful and common pattern was to use a stack machine, right, where you have a flat set of instructions that allow you to build randomly complex systems. And what happened is that after working on Skia and working on WebGPU, I saw this pattern actually coming up more and more. So much so that it gave me an idea for a silly experiment. So I thought, okay, what would be an instruction set that would be simple enough that we can work with it, that would be high level enough that it's like easy to work with, but also low level enough that we could potentially have like high level languages that could target this instruction set. Mm-hmm. And is there one that would come to mind? Maybe like just.
I mean, you hear a lot about. I mean, I guess Spurvy only touches the shader side, but it's also about what you're talking about. I guess is also touches just pushing instructions to the GPU apart from actually the code running on the GPU. So pushing data. Yeah, I don't know.
Yes. Yeah, no, I mean, and you are way ahead of me, of course. But exactly, so one instruction set I was thinking about was, so there are a couple of candidates,
yeah.
But one that came up was WebAssembly.
Oh, yeah.
Because there is a really large ecosystem. And I thought, so originally I thought it's actually pretty low level, so maybe hard to work with. I didn't know anything about WebAssembly. I mean, now knowing what I know now, it's actually like pretty high level. I think I was checking, okay, how many instructions there are, and there are many. So I was like, oh, that sounds rough, but actually a lot are like duplicates. Like I couldn't believe how high level it was basically. So yeah, I thought, okay, let's play with WebAssembly. So here I have a piece of C code, which something very simple. There is no even operator overloading, nothing. We have our own cosinus definition, and we compile it to WebAssembly.
Yeah.
And it's only a small set of, so it's a pretty small set of instructions. So here I have it running on Canva. So we can have a look at the code quickly. So I have a 2D Canva. I have a loop for each pixels. I invoke the WASM file and put the image data and display the shader.
Yeah.
As you can imagine, a CPU shader, exactly. So as you can imagine, it's pretty slow. And even though it's like such a simple, so we're running at 21 FPS. So how could we make this faster?
I mean, we can either translate it to Wigzil or move the loop to WASM. But I guess you did the former. Did you translate this to Wigzil?
So yeah, and actually, yeah, and again, you're way ahead of me because the original. So first, because I needed to have like this Weasel stack machine, I didn't even think about unrolling it or transpiling it to Weasel. I was really thinking, we load the instructions in the storage buffer, and then we interpret the storage buffer. And so which I have here in this demo. So this is demo 2. And what we do here is that we actually load the instructions into a storage buffer and we interpret it in a Weasel shader. I think it is faster, but obviously, and this is the thing I hadn't realized at the beginning, and this is where you're ahead of me, is that of course this is extremely inefficient because the memory registers are not static. You just have like to do so much work. Actually, if you think about it, it's actually pretty crazy that we get to 40 FPS, knowing like how inefficiently we're doing it.
Yeah, but it's still like it's definitely a good stepping stone, right? It's an interesting approach, but yeah, you like it's interpreting something data on the GPU is not very efficient.
Exactly. I had to learn this hard way. I had no idea, right? You try things and then you realize that. But once, if your memory registers are like non-statically, it's actually extremely efficient. So yeah, then the third approach was to transpile the instructions to WASM.
I knew it.
And yes, so let's have a look.
Oh man, this is crazy.
So I have a couple of shaders we can look at. So of course the first thing I tried was the XorDev shader. So here we're running at 120 FPS. I think the frame time is okay. I mean, spoiler alert. At some point I thought, I'm going to be able to be as fast as native with a shader. But actually we're always going to be slower at some, and we can have a look why.
Okay.
But I mean, here the performance is pretty, I would say, promising. Here's another one. So of course now it's and let's have a look at the code. So first, here we have no operator overloading, no nothing. But now we can start to have fun, right? So we can start to use operator overloading. We can start to, instead of having our own trigonometric function and so on, we can call directly the WebGPU definition. So here I have the whistle.h file where we can define our own operations to be invoked by WebGPU. We can do the whole operator overloading. And now the code looks exactly like the original shader code, right?
Yeah. Oh, wait, I can see even like loop unrolling. That's a very, very nice way to, I guess, use the compiler. Yeah.
Yes.
Oh, that's crazy.
And so this is where things starts to be a bit. I mean, let me show you a couple of demos, but this is where at some point I feel like, so it's pretty fast, but we won't be able to be as fast as. But maybe let's have a discussion because.
Yeah.
So just some more demos. Of course, this was Shader's Gambit from last year.
Love that video.
Cool, thank you. So if I open the shader, I mean, it's literally the same code. We have the anti-aliasing, everything. So it's literally, and this is where the performance is a bit slower. So we have these huge remarching functions which are inlined.
Okay.
And I'm like, these big functions, they shouldn't be inlined. I mean, in WebAssembly, it supports functions and so on. And this is where actually, so then I try to, for really big functions, to not inline them and have them, like be interpreted as native WASM functions, which works. But then the performance, I could not match the performance of really like.
Really?
But maybe to be investigated, yeah. It was just a silly experiment. Obviously, I'm not using this it was more like a thought experiment.
Yeah.
I'm not using this to do anything serious. And of course, so when you make these silly experiments, the question is always, can it run Doom, right?
Yeah.
So you tell me.
Oh my God. No way. You didn't do that. Oh my God.
So that's 120 FPS. No, so here I'm cheating completely. I'm not obviously running Doom because Doom is not structured to be parallelized.
Yeah.
This is like a Doom shader, which I need to give proper credits to.
Yes.
To the author, but again, I could easily port it to.
Oh my God.
And where things get interesting. So is this useful? I'm not sure. It was a fun thought experiment. What's really cool is that we can actually use these high-level C++ language features like templating and operator overloading. And this, I think, relates a lot to type GPU, where I'm using it also, I'm using type GPU a lot to write compute shaders, and suddenly you can use language features which are not available in Weasel, which I think is really cool and interesting.
Yeah, yeah. I mean, I feel like it opens up similar things, as you said, to what type GPU does for JavaScript developers or TypeScript developers. I see a lot of people nowadays go the route of writing their game engines or games in a different language like C or C++ or Zig or Rust, and then they convert it to WASM and run it on the web. And they can still target WebGPU, but they have to write the shaders in Wigzell still. So this could be a really nice solution for them to be able to write. I mean, they're targeting WASM anyway, so you're not going to have to add support for all of these different source languages, right? You just have to support WASM, which you already do, and all of them can benefit from that inherently. I feel like that's very beautiful.
One thing, again, maybe here I'm not privy into all the information, but one thing that always feels a bit like an anti-pattern is when you have a programming language like Weasel, and some internals of the language are not available to us developers. So I'm thinking about function overloading. They use it for the internals,
Yes.
but we don't have access to it, or even templating. And usually it's not a good sign. I feel like if we had templating in Weasel, that would be great. Function overloading also sounds like it could be very useful. And in some ways, when I use type GPU, these features are available to me.
Yeah.
One example which is very, very compelling is the interpolate function, which I'm using a lot, by the way. You had given me the definition, where you have arbitrary number of array, and then you instantiate the right Weasel functions that to use the interpolation.
Yeah, yeah.
So some of these higher level language features sometimes are, I think, very useful to write shaders. And
Yeah, I agree. I think this is really really awesome. I mean, how did this start? Was it just like, can this be done, or what was the motivation behind it?
Yeah, all right. So this is a joke and this is a silly experiment, but it started from a very serious thing, and then I derived the idea of, okay, what if we would use WebAssembly, and so that's the result. But so now let me show you the real thing.